Welcome back! In the last video, we talked about navigating on land and at sea. In this video, we'll be talking about latitude and longitude. You might have heard these words before, but let's have a refresher on what they are. Latitude and longitude are a way to describe where you are on the globe, similar to the lines you have on a 2D map, but covering the whole Earth. They are represented by coordinates such as 55.95085 and -3.17456. Those are the coordinates for dynamic Earth. We'll explain more what they mean in a minute.
Latitude lines run laterally. They are the rings that go around the Earth in a west to east direction. And they change in circumference, or how long the line would be if you travelled along it, depending on how far north or south they are on the planet. The equator and the tropics of Capricorn and Cancer are all circles of latitude. The equator is known as latitude of 0 degrees. Anything north of this is positive degrees and south is negative degrees. So let's look at the coordinates we gave before. The first number is the latitude. It's positive, so we are about 55.9 degrees north of the equator. The second number is the longitude.
Longitude lines are all the same length and they go all the way around the planet, crossing over each other at the north and south poles. A line of longitude is called a meridian. As there isn't an obvious point to call 0 degrees, like the equator is for latitude, one was chosen and called the prime meridian. It is where 0 degrees longitude is, and it goes through the Royal Observatory in Greenwich, London. This is why we call it Greenwich Mean Time, or GMT.
If you go west of London, the coordinates would be negative, and if you go east, they would be positive. So let's check back in with our coordinates here at Dynamic Earth. Remember, the second number is the longitude, and it's negative, so we are 3 degrees west of the prime meridian in London.
On land, it was much more difficult to work out longitude than latitude. This is because it relied on accurate timekeeping in 2 different places and an observation of the same event in both places.
A way for us to determine longitude nowadays involves comparing the time difference between noon GMT and noon where you are, determined by when the sun is at its highest point in the sky. Comparing the time you measured noon on a clock set to GMT and 12 midday will give you a time difference of plus or minus minutes or hours. As a general rule, an hour in time is around 15 degrees difference. So since noon in New York City happens at around 5 p.m. in Greenwich, London, so 5 hours after, that means that New York City is around 75 degrees west of GMT. That's 5 times 15 degrees. In the sea, it was more difficult again. The tools to take these measurements, a pendulum clock and a telescope, don't work very well on a moving sea. The rocking of the boat would mess up the clock's pendulum, and telescopes only really work on still ground. Otherwise, you'd be moving around too much to keep the thing you're looking at in view.
So, why is it useful to know all of this? Well, latitude and longitude are the main way by which we describe where we are in the world. Throughout history and present day, we use the coordinate system to tell us where we are. If you use a smartphone map service, it will be able to tell you what your coordinates are in the format of latitude and longitude.
Historically, without GPS, navigation was something people making long journeys struggled with. However, latitude was relatively easy to work out using a sextant. A sextant works by measuring the angle between 2 things in the sky, such as the horizon and a celestial body, which is something in space like the sun or another star. You can use this angle and the time you measured it on an aeronautical chart to find out your latitude, and this is called celestial navigation.
Longitude was even more difficult than that. So difficult to be accurate about, in fact, that something called the Board of Longitude was set up by the British government in 1714, offering a large cash prize for any scientist that could come up with a way to accurately work it out. Working out longitude was very important to the British government at the time because it had a huge impact on trade, including the trade of enslaved people from the west coast of Africa to North and Central America, and between many other places in the world.
There were lots of ways to work out longitude to different degrees of accuracy, most of them involving comparing the local times of an event visible from 2 places. One way of doing this uses chronometers, or watches. If you have a watch accurately set to GMT, you can compare this to local time somewhere else and convert the difference in hours into degrees. That's quite a lot of information, so we'll let you do some activities in your classroom now. Have a go at calculating your latitude and the height of really tall things using the length of shadows.